minus 2 cosine x. Now, in 2.3, we actually are allowed to use the formulas now. Okay, so we're allowed to use the shortcuts. So we don't have to do a limit, h goes to 0 anymore. So I use, first of all, the fact that both of these are separated by subtraction, right? Which means I can do the derivative of each one separately. And then let me look at the 3 times the x squared. The 3 in front is a constant. So I'm just going to bring that 3 down. Let me put f prime of x here. Anytime a constant's attached to a function, you just bring it down. Now, what's the derivative of x squared? 2 times x. And that's using the fact that the derivative of x to the n is nx to the n minus 1. That's what we did last class. What did we call that? The what rule? Power rule. Okay, any questions there? Okay, the 2 in front of the cosine is a constant, so I'll bring it down. And now you need to know what the derivative of cosine x was. And isn't that the bonus? It's negative sine x. But it's also on your formulas now, right? On your formula sheet. So everyone should just know now the derivative of cosine of x is negative sine x. And I need to make sure I'm multiplying that, right? So I'm going to put parentheses around it. So my final result is 6x plus 2 sine x. That's it. Does that make sense? Okay. Any others? Do you have a specific? Okay. Number 3 and 2. Yeah, these are a little tricky. Okay, let me do 3. Which one do you want me to do? D? Okay, let me do my best to draw this. So the graph does something like this. Okay. So let's talk about its derivative. The derivative of this function is a new function. And the value of that function is basically the slope of the tangent lines here on this graph. So let's go for the things that are easiest to determine first, which would be wherever the derivative is 0. That means the slope of the tangent line is 0. So if I look at the top, this bottom point, and this top point, would you agree that at those 3 points, your derivative, your slope of your tangent line, must be horizontal? Which means that the slope is 0 at those points? Okay, so I'm gonna put the derivative next to this, I guess. So at 0, at an x value of 0, I should be at 0. And then somewhere to the right, I have another place where I'm 0, and then to the left, another place at 0. So the x values there correspond to the x values on this graph on the left. Does that make sense or not? That's okay? All right. Now, let's look at this region over here, the left side of that dot. Tell me about the derivative there. It's positive, right? It's positive. Now, it's positive, and they're pretty steep tangent lines, aren't they? I mean, like, this is a pretty steep line, steep line, steep. And then what happens is it slowly starts to flatten out, doesn't it? So it's a very, very steep positive slope means a very big positive number. But then it slowly starts to approach 0. So on my graph here on the right, I know that my derivative has to be positive numbers, and steep means big, so it's got to go kind of up like this. All of those points here on this graph are positive numbers. and they're pretty big until you get closer to that place where it's supposed to be 0. That kind of makes sense? Now what happens in this green region? What's my slope in there? My slope is negative, which means my derivative needs to be negative, and it needs to come back to 0. So I'm going to draw my graph dropping below the x-axis, negative numbers, and then coming back to 0. And then where does it have to go? In this next little region right here, that little purplish one. The slopes are positive, right? So my derivative needs to be positive over there, but then again come back to 0. And then, in that last region on the right, what's the slope of the tangent line over there? Slope is negative, right? So that means that my blue function on the right side needs to be negative also. So if I were looking at my options there, for parts A, B, C, and D, I have to choose either 1, 2, 3, or 4. I would say, what, 3? How about part B? I think B is an interesting one. Your graph looks like this. Goes up, down, up, like that. Now I'm going to do the derivative on top of this one instead of to the side. So is my derivative ever 0? Doesn't look like it, right? I don't have any nice flat places. I have corners. What happens at corners? Derivatives are undefined, right? So let's look at the left side. What does the slope of the tangent line over here look like it is? It's positive, right? But then it's also constant because it's a line. So I would say that my derivative needs to be a positive constant. So just a flat line, somewhere positive, right? Until I get to the corner, and that's where it's undefined, so I put an open circle. Then what does my slope do, my derivative, in between here and here, the green part there? It's negative. So it switches, at that corner, it switches from positive to negative, and it's constant also. So I'm going to put something negative until I get here, it's undefined again. And then I switch to positive again, and it's constant. And it looks like it's the same slope as that yellow one on the left side. So I should have the same y value. So it should look something like that. Is that kind of making sense now? Okay. Any others? Okay, good. All right, that's a great question. Number 39. Number 39 on 2.3 says, show that the curve y equals 6x cubed plus 5x minus 3 has no tangent with slope of 4. No tangent with a slope of 4. That's what the problem's stating. Now, I'm going to bring up this program again quickly. 6x cubed plus 5x minus 3. You don't, oh, I put and. There's the graph, okay? There's the graph. Now, it's saying for us to show that this function here never has a tangent line that achieves a slope of 4. So how can we show that? Well, what is the slope of the tangent line? The slope of the tangent line is the derivative, isn't it? That's what it is. And what is the derivative of this function? Now remember, we're in section 2.3, so we can use the shortcuts. So I'm going to look at the fact that I've got three terms, right, separated by addition and subtraction. So I can do the derivative of each one of those individually. I have a 6 in front of a function, so the 6 will come down. And then I have to take the derivative of x cubed. What's the derivative of x cubed? 3x squared, right? Plus, what's the derivative of 5 in front of x? Well, 5 comes down, but then what's the derivative of x? 1. 1. We all need to remember that. Derivative of x is 1. So that's going to be times 1. And then minus, what's the derivative of 3? 0. Derivative of constant is 0. So my derivative is 18x squared plus 5. Do you agree? That represents the slope of the tangent line. And I want to show that that's never equal to what? 4. So let me try and see if it ever is 4. I'm going to take that derivative, and I'm going to ask myself, is this ever equal to 4? It's a question I'm asking myself. So how do you solve this equation? You could subtract 5 on both sides. And I think here you can almost even stop. What's your conclusion here? I mean, think about x squared, right? X squared is a positive number, no matter what. As long as we're dealing with real numbers, which is what we do in this class. X squared has got to be positive. The worst case scenario is it could be 0. But then you multiply it times 18, it's either going to be 0 or a positive number. There's no way it's ever going to be negative. So this has no real solution. This right here, no real solution. Well, there are solutions that are complex numbers. So when you say no real solution, you're saying there's no real number that would solve that. I mean, there's an imaginary number that would work. That's how you would answer it. Does that, okay. Sure, what's up? I added number 7 to the homework. Find the slope of the tangent line of the curve. Okay. Yep, I'm with you. So find the slope of the tangent. So they give you the curve y equals 3 plus 4x squared minus 2x cubed. And they want you to find the slope of the tangent to the curve at the point x equals a. So this is back in 2.1 where we are first learning about the derivative. So I'm sorry? Well, there's two definitions. We have to use the limit definition to find the tangent here in this section. That one, you can use that one, or you can do limit h goes to 0. So this is what the two you could do. Limit x goes to a, f of x minus f of a over x minus a. Or you could use limit h goes to 0, f of a plus h minus f of a all over h. Yeah, the first one looks pretty bad. The second one even looks bad. No, I mean it can be done. It's the algebra that would be challenging, right? So trying to see. Let's just take a vote. We'll take a vote. How many of you want me to work it? I don't mind doing it, but I just, if you think it'd be helpful for you to see all the algebra behind this. Okay, Then tell me which one you want. So, how many you want the first one? First one? Second one? It's about even. So I'll do it the way that you did it, okay, since you asked the question, all right? So I'm going to do it the first way. All right, so I want the limit of x approaching